All right, guys, this is our first week of in-person school. If you decided to stay home virtually, then this is going to be your lesson for the week. Things will be a little different each week, but for this first week, we're going to concentrate just on one lesson. All right, so we're looking at lesson 10, unknown angle proofs, proofs with constructions. All right, so let's go ahead and hit our opening exercise. It says, in the figure to the right, segment AB is parallel to segment DE, and segment BC is parallel to segment EF. Prove that B is equal to E, and it says there's a hint. Extend segment BC and segment ED. All right, so if I do that, and you don't have to take a ruler and do that, you can do it just, however, but I kind of like to take my ruler because I want to make sure that I see what it's telling me to do. And if I extend that, look what I notice. They come together at a point. All right, so let's look at this. We are going to write a proof. All right? We're not going to write a full proof. All we want to do is just prove our points here. All right, so it says that AB is parallel to DE, and that BC is parallel to EF. All right, so we need to look at this as parallel lines and transversals. All right, so I'm going to give this a letter, this new angle, and I'm going to label it angle Z. All right? So I have angle B here, I have angle Z, and I have angle E. I'm going to pretend like this is not here, and I'm going to look at these two parallel lines and this as a transversal. I am given angle B. I'm trying to prove that B and E are equal. So I want to see if there's anything I can prove here that deals with angle B. I know that angle B is congruent to angle Z, or is equal to Z. Why? Well, if parallel lines are cut by a transversal, then alternate interior angles are equal in measure. They are alternate interior angles. So if parallel lines are cut by a transversal, then I know that alternate interior angles are equal in measure. So I've proven that angle B is equal to angle Z. Okay, so now let's flip over here and let's look and pretend like this part's not here and look at this. Because remember, my goal is to get to B and E. All right, so now I'm going to pretend like angle B is not there anymore. And let's look at this. What do I know here? If these are parallel lines, then this is my transversal. What do I know about Z and E? Well, I know Z is equal to E, same reason. If parallel lines are cut by a transversal, then alternate angles are equal in measure. So, a couple of lessons ago, I gave you a paper and it had a bunch of properties and things on it. Guys, I cannot tell you how important it is for you to go back and look at that and make sure you know these properties. All right, we kind of missed out on a big chunk of algebra last year because we got cut short, almost 3 months early. So make sure you're looking at that stuff because it's important. Because I only have one more thing here. Guys, look at this. I know B is equal to Z and that Z is equal to E. So I can prove that B is equal to E by what we call the transitive property. All that's doing is telling me if one thing is equal to another, and that other thing is equal to something else, then the original one and the end one is equal. All right, so that's transitive property. In the previous lesson, you used deductive reasoning with labeled diagrams to prove specific conjectures. What is different about the proof above? Adding or extending segment lines or rays, referred to as auxiliary lines, is frequently useful in demonstrating steps in the deductive reasoning process. Once segment BC and segment ED were extended, it was relatively simple to prove that the two angles congruent based on our knowledge of alternate interior angles. Okay, so what this is basically saying is, when I first looked at this diagram, I'm sure a lot of you went, I have no idea how to prove that. Because they're not connected in any way. We haven't learned anything that way. So how am I going to prove that? But then when I created my auxiliary lines, I was able then to see, oh, I have parallel lines and a transversal. Now I can use the knowledge that I have. Sometimes there are several possible extensions or additional lines that would work equally well. For example, in this diagram, there are at least two possibilities for auxiliary lines. Can you spot them both? Okay, so it tells me that segment AB is parallel to segment CD. And it wants us to prove that Z is equal to X plus Y. All right, so can you see where we might draw our auxiliary lines? It says there are two possibilities here. All right, if you can't, that's okay. You will get better at recognizing and get better at figuring that out. So the nice thing is they go on to show us where we might extend our auxiliary lines. So, let's look at the first possibility. The first possibility says that I can extend this line right here. They dotted it to show you where the extension is. So it says, once again, AB is parallel to segment CD, and I want to prove that Z is equal to X plus Y. So it says, extend the transversal as shown by the dotted line in the diagram. Label angle measures V and W as shown. Well, when I extend, guys, look at this. What do I create? I create a triangle, which may possibly come in handy when I'm trying to figure things out. What do you know about V and X? Okay, so it automatically asks, what do you know about V and X? Well, V and X are what kind of angles? They are corresponding angles. Because here's my parallel line. I'm going to pretend like this segment right here does not exist right now and just look at it as two parallel lines and a transversal. I know that V and X are corresponding angles, which means they are what? That they are equal. All right? About angles W and Y. So what do you know about angle W and Y? Well, once again, it doesn't take much there I don't have to do any extension. I see that they are vertical angles. All right, so I'm going to write that down here because we may use this. W and Y are vertical angles. And it says, how does this help you? Well, let's look at this. Write a proof using the auxiliary segment drawn in the diagram to the right. Okay, so let's look at this. We created a triangle here. We need to figure out that Z is equal to X plus Y. All right, now, a lot of times with proofs, it's very hard to figure out where to start. Okay, and this was not the exact way that I wanted to introduce proofs to you by doing it virtually. But, you know, we might as well just go ahead and hit it head on because this is what we have. Okay, so let's think about this, and that's why I'm helping you out. And most of the time, I will never give you a proof that is not at least partially done. All right, I'm never going to just say, here, create a proof on your own. All right, so let's look at that new triangle that we created. And let's think about what we know. Well, if you remember, we've talked about exterior angles, and we've talked about how to find them, and we've talked about remote interior angles. So using that information, what do I know? Well, I know that Z is equal to V plus W. All right? And I know that because the exterior angles of a triangle equals the sum of the two interior or remote interior angles. Okay? All right. So now with that being said, I know that Z is equal to V plus W. All right? Now, how does that help me? Well, we talked about, remember we're trying to get to the point of Z is equal to X plus Y. We talked about something that's going to help us here. What did we talk about V and X? We said X was equal to V because if parallel lines are cut by a transversal, what did we say? These are corresponding angles. Corresponding angles are equal in measure. Okay? All right, so now we know that X and V are equal. What else do we know? Well, we talked about Y and W. We said that Y and W were what? We said they were vertical angles, so they're equal in measure. Okay, so here's what I know. I know that equal to V, I know that Y is equal to W. Alright? Now, what did we figure out? I can substitute. Alright? I already know that Z is equal to V plus W. Okay? Because I know that, I know V and W are equal to X and Y. So therefore, I can say Z is equal to Y plus X because of the substitution property. Okay? Alright, so the second possibility for an auxiliary line, notice is they went ahead and divided that angle. Okay? So it says draw a segment parallel to segment AB through the vertex of the angle measuring Z degrees. This divides it into angles 2 parts as shown. How do you know, or what do you know about angles V and X? V and X would be what? Alright? And what do you know about W and Y, and how does this help you? Alright, so we're going to write a proof to look at this. Alright, so once again, first thing, we're going to start off with, what do I know about V and X? Their corresponding angles. Alright. And what do you know about W and Y? They're also equal in measure. They are corresponding angles. Alright, so I'm going to start off with immediately, I know X is equal to V. Why do I know X is equal to V? Because if parallel lines are cut by a transversal, corresponding angles are equal in measure. Alright, so if I know that X and V are equal, remember my goal is to figure out that Z is equal to X plus Y. Alright, and Y is equal to W. Why do I know that? Because once again, if parallel lines are cut by a transversal, and guys, I'm just going to put little quotation marks because I don't want to take much more time to write this out. Alright, so now I know that Z is equal to V plus W. And that's what we call the angle addition postulate. Alright. We're going to start getting into keeping a notebook and getting those postulates and things written down. Alright, so angle addition postulate. Alright, and because I know that, guys, I already know that, look at this, I know V is equal to X and W is equal to Y. So I can say Z is equal to X plus Y by substitution property. Okay. What do you know about V and X? we'll just, we're going to kind of skip that part right here. And we'll go to our examples. In the figure at the right, segment AB is parallel to segment CD, and segment BC is parallel to segment DE. They want us to prove that angle ABC, this angle right here, is equal to angle CDE, this angle right here. Is an auxiliary segment necessary? Alright, so is it necessary to create an auxiliary? You may say yes, you may say no. If you want to extend things, you can. If you are capable of seeing them the way they are, then maybe it's not. Alright, so I want to prove that this angle right here is equal to that angle right there. Alright, so we're going to look at a couple of different things. Let's just look at, let's pretend this line is not here. And let's look at this set of parallel lines. And what would I know? I would know that the measure of angle ABC is equal to the measure of angle BCD. So I know that this angle is equal to this angle. Okay? I know those two angles are equal because they are alternate interior angles. So, if parallel lines are cut by a transversal, alternate interior angles are equal in measure. Okay? Now there's not much more that I can do here that's going to help me. So now I'm going to flip and I'm going to pretend that that segment's not there. And I'm going to look at this as two parallel lines and a transversal. What do I know? Well, I know that angle BCD is equal to angle CDE. So the measure of angle BCD is equal to the measure of angle CDE. Why do I know that? Because once again, if parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Look, because one thing is congruent to the, look at this. Notice they're congruent to, they're equal to the same thing. So because of transitive property, I know that the measure of angle ABC is equal to the measure of angle CDE by transitive property. Okay? All right, look at number 2. In the figure at the right, segment AB is parallel to segment CD. Segment BC is parallel to segment DE. I want to prove that B plus D is equal to 180 degrees. Is it important to do an auxiliary line? Maybe. Okay? So here's what I would do. I would give this a C. I would give this a letter because we're going to need it. Alright, so label your C degrees. Okay. So, once again, you can extend if you want. It is totally up to you. Alright, so let's start here. What do I know about angle B and angle C? Angle B and angle C are equal because they are what? alternate interior angles. Okay? Now, let's look at this. Now I'm going to look at, here's my parallel lines, here's my transversal. Okay? I want to look at these two lines now as parallel lines, and here's my transversal. If I'm looking at those as parallel lines and as a transversal, what do I know about the angle C and angle D? They are same side interior angles, and they equal what? So C plus D is equal to 180 degrees. All right? If parallel lines are cut by a transversal, same side interior angles, are supplementary. In other words, they equal 180 degrees. Alright, so look, I'm getting closer. All I need now is to figure out B instead of C. Well, look what I proved up here. I proved that B is equal to C, so now I can substitute. Because B is equal to C, then I can put B in there. B plus D is equal to 180 degrees because of substitution. Okay? Alright. Alright guys, I'm going to stop. You do not have to do this one simply because I know it's overwhelming. This is a lot of stuff. Alright? But it's okay. We're going to work on it and we're going to keep working. Alright guys, have a great week. If you need anything, reach out.